Okay, this is the second video in the activity 13/15 video, or activity 13 and activity 15 video series. So lesson 13-2 is titled Isosceles triangle. So it's the second and last video in activity 13. Our learning targets for this one will be to introduce theorems about isosceles triangles, and then we won't actually prove any theorems in here, okay? Change my color to something different because I'm tired of this color. Purple. Okay, so an isosceles triangle, what does that mean? You may have heard of this before. It's a triangle with at least two congruent sides, okay? So two sides that are equal, as we commonly say it. So let's talk about the parts of an isosceles triangle. We have the legs, which are the two congruent sides. So over here we have a leg and a leg on my triangle. The base is that other side, okay? And base angles, these are the angles that are opposite the legs. So when I say opposite, I see my leg right here, and then there's always an angle opposite a side in a triangle. In this case, these two base angles will be opposite the two legs. All right, we have two theorems to talk about, the two theorems called the isosceles triangle theorems. We have part 1 and part 2. Part 1 says that if two sides of a triangle are congruent, then the angles opposite those sides are congruent. So we know this two sides of a triangle being congruent means it's an isosceles. So another way to say is that if a triangle is isosceles, then you can say that the angles opposite those sides are congruent, or you can say then the base angles are congruent. Okay, so if we look at our example, we're going to say that the two sides that are congruent, we have it marked right here, AB and BC. So segment AB, side AB, and side BC, if those are congruent, then the two angles that are opposite are angles 2 and angle 3. We can say that angle 2 is congruent to angle 3. All right, basically what this says is that for every isosceles triangle, we know that the sides are congruent, two sides are congruent, and two angles are congruent. For the part 2, we are going to go the opposite direction. It says if two angles of a triangle are congruent, then the sides opposite those angles are congruent. So how about we say if angle 2 is congruent to angle 3, then the sides opposite are AB and BC, and they are also congruent. So basically, when we're given a triangle and if we only know that two angles are congruent, I can then say it's isosceles, okay? And then I can find which sides will be congruent because they're opposite the two angles that are congruent. All right, so let's use these two theorems to solve some problems. Number 1, the measure of the vertex angle of an isosceles triangle is 80 degrees. What is the measure of a base angle? So I draw my isosceles triangle, all right? So that we'll do my vertex angle at the top. We'll say it's 80 degrees. I know it's isosceles, so those two are the same. Those two are congruent. So that means these two angles are also congruent. So I know what I can do to find these two base angles. I can take 180 minus my vertex angle, because we know the three angles in a triangle add up to 180. This is 100 degrees. Okay, so I know that these two angles, these base angles, will add up to 100 degrees. So since they're the same, since they're equals, we can take 100 divided by 2, and then we have that each base angle is equal to 50 degrees. All right, P2. The measure of one base angle of an isosceles triangle is 25 degrees. What is the measure of the vertex angle? So isosceles triangle, we know my base angles are opposite those, so we'll say this is 25 degrees. If I know one base angle of an isosceles triangle, I automatically know the other is the same. So 25 degrees. Let's find this vertex angle. All we have here, two angles in a triangle. We can find the third one by subtracting the sum of those two from 180. So 25 times 2 is 50 degrees. Okay, so the vertex angle will be 180 minus 50 degrees to give me 130 degrees. As you can see, I did not draw my triangle to scale, but this is kind of just for me to see what an isosceles triangle is going to look like, okay? And so my triangle actually probably going to look something like this. Okay, so that would be a more accurate drawing of your triangle. It's just for a visual for me, okay? It doesn't have to be exactly to scale. All right, number 3. The measure of a one base angle of an isosceles triangle is a third of the measure of the vertex angle. Find the measure of each angle in the triangle. Okay, so look, I'm going to use these angle measures from the triangle up here. All right, so I know that our vertex angle is angle 1. Our base angles are angle 2, angle 3. So I know that the measure of one base angle of an isosceles triangle is a third of the measure of the vertex angle. So I can say that the measure of angle 2, maybe, say that's one of the base angles, is going to be equal to 1/3 of the vertex angle, which is angle 1. And then since the base angles of an isosceles triangle are the same, we can say the same thing for the measure of angle 3. Okay, so using the triangle sum theorem, I know that the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 degrees. Right? So let's plug in what we know for angle 2 and angle 3. Measure of angle 1 plus 1/3 the measure of angle 1 plus, again, 1/3 the measure of angle 1 is equal to 180. So we can think of the measure of angle 1 times, we want to combine these like terms now. You can think of this is just 1 times the measure of angle 1. So I need common denominators. So I'm going to write that as 3/3 times the measure of angle 1. Okay, we have common denominators now, so 3 plus 1 plus 1 will give me 5/3 times the measure of angle 1 is equal to 180 degrees. So let's solve this. Multiply both sides by 3 to get rid of that 3 in the bottom. So we get 5 times the measure of angle 1 is equal to 180 times 3, which will be 540. And then divide both sides by 5, so the measure of angle 1 is just equal to 108. Okay, so we're going to find the measure of each angle though. Alright, so this is the vertex angle. So to find the measure of angle 2 and the measure of angle 3, we do 180. Or actually, you know what, guys? I'm just going to use this formula here. I know that measure of 2 and measure of 3 is just 108 divided by 3. So measure of angle 2 is equal to 1/3 of 108. So 108 divided by 3 is 36 degrees. So the measure of angle 2 is equal to 36 degrees. And the measure of angle 3 is also equal to this, 36 degrees. And with that, we're finished with number 3. Number 4. Juan said that he drew a triangle with angles of measure 118 and 30 degrees. He said that he can choose the measure of the third angle so that the triangle will be isosceles. Do you agree? So I'm going to say a big old no. There is only one choice for the third angle, which is, so we do 118 plus 30. Subtract that from 180, you get 32 degrees. So which is 30 degrees, and this, of course, would not make, this means the triangle is not isosceles. So I guess instead of saying no, I'll say I disagree. So he cannot just choose any old angle. There's only one possible angle that can make this triangle a triangle, because you know the triangles add up to 180. If he was to say that the third angle was 30 degrees, you'd add those 3 angles up, and you would not get 180 degrees. So I strongly disagree with this one. Number 5. Jennifer claims that if an isosceles triangle contains an obtuse angle, then the obtuse angle must be the vertex angle. Is she correct? If so, justify your statement. If not, give an example. So let's assume that she wouldn't be correct, like that she's incorrect. That would mean that okay, no, actually, let's do this. Let's assume that we have that the base angles would be the vertex angles. Okay, if the base angles or the vertex is an excuse me, that's not what I meant. Let's assume that the obtuse angle are the vertex of the base angles. That means we would have two base angles. Okay, two obtuse angles. This is not possible in a triangle because obtuse angles are greater than 90 degrees. So say if I had 91 degrees and 91 degrees, that would give me 182 degrees, which is over the over what the sum of the angles in a triangle is. So there can only be one vertex angle and obtuse angle, so it would have to be this vertex angle. So we'll say correct. There can only be one obtuse angle in a triangle, so it can't be the base angles, which are two of them. Must therefore be the vertex angle. Okay, number 6. Using the figure PQ is congruent to PR, and using the figure we know that PQ and PR are congruent. We also know that TQ and TR are congruent. We want to explain why angle 1 and angle 2 are congruent. So TQ and TR are congruent, meaning that this is an isosceles triangle, so I know that angle 3 and angle 4 are congruent. And then I also know the outside triangle is an isosceles triangle, so those PQR and PRQ are congruent. Okay, so let's say this. So that means the measure of angle PQR is equal to the measure of angle PRQ. And then we also know that the measure of angle 3 equals the measure of angle 4. Okay, so we also know that PQR is angle 1 plus angle 3, right? So the measure of angle PQR is equal to the measure of angle 1 plus the measure of angle 3. And then PRQ is the measure of angle 2 plus the measure of angle 4, right? This is the angle addition postulate that tells us that. Okay, so I know that these two are equal, and then I also know that 3 and 4 are equal. So I'm going to plug in the measure of angle 3 for the measure of angle 4, and I'm also going to set these two equal to each other. So I've got now the measure of angle 1 plus the measure of angle 3 equals the measure of angle 2 plus the measure of angle 3. We subtract these measure of angle 3's away. Then we're left with the measure of angle 1 equals the measure of angle 2, and thus angle 1 is congruent to angle 2. And that's it right there. Boom. Number 6. Number 7. If I know that AB is congruent to BC, which is marked for us, and angle 2 is congruent to angle 4, explain what triangle ADC must be isosceles. Okay, so since I know that ABC is isosceles because those two sides are congruent, I know that the measure of angle BAC is equal to the measure of angle BCA. Alright, and these, so I know the measure of angle BAC, so I'll write this on the left, it's just a measure of 2 plus the measure of 1. Measure of 1 plus the measure of 2. That's just by the angle addition postulate. So then on the left side will be measure of angle plus the measure of angle 4. Oop. What I do know is that the 1 and 2, or 4 and 2 are congruent, okay? So I can plug in the measure of angle 4 for the measure of angle 2, since they're the same. Subtract both of those, subtract the measure of angle 4 from both sides. We get the measure of angle 1 is equal to the measure of angle 3. So angle 1 is congruent to angle 3. Awesome. We know that by the isosceles triangle part 2 that if those angles are congruent, then these two sides are congruent. So triangle ADC is isosceles. And we're done with that one. P7. Awesome. Fun. P8. Solve for x. Alright, so this is an isosceles triangle based on the fact that those two are both 5. So that means that these two angles have to be equal. So our equation we can do is set them out, add all three of the angles up to 180, because I know this one will also be 2x plus 3. So I can say that 2 times 2x plus 3 plus 3x minus 1 is equal to 180. So 4x plus 6 plus 3x minus 1 equals 180. 7x plus 5 equals 180. 7x equals 175. 175 divided by 7 is 25. So x is equal to 25. That is number 8. Number 9. Triangle ABC is an isosceles triangle with vertex angle B. Stop here, draw your triangle. I know it's an isosceles triangle, and my vertex angle is between my two congruent sides, so it's right there. So we'll call this one A and C. Okay, AB is 5x minus 28. AC is x plus 5. And then BC is 2x plus 11. So I know that two of my sides, AB and BC, are equal. Their lengths are equal because they are congruent, because it's an isosceles triangle. So my equation to solve for x will be, because we're determining the length of the base, which is AC. We cannot find AC until we've got x. So my equation for this one would be 5x minus 28 is equal to 2x plus 11, because those two sides are equal. So let's solve for x now. 3, subtract 2x from both sides, add 28 to both sides. We're left with 3x is equal to, what is it, 39. So x is equal to 13. All right, cool. Now to find the base, which is AC, we just plug in 13. So 13 plus 5, so AC is equal to 18. And that's all we want. Cool beans. Number 9 is done. Number 10. In triangle M and O, angle M and angle O are congruent. So, like how we usually draw our triangles, let's say M and O are down here. They are congruent. So that means these two sides are congruent as well, because it's an isosceles triangle. So this will be angle N at the top. So if MN is 4x plus 25, if NO is 2x plus 45, and then MO is 3x minus 15, we want to find the lengths of the three sides. So in our equation, we're going to set the equal sides equal to each other, which are represented by 4x plus 25 and 2x plus 45. So 4x plus 25 is equal to 2x plus 45. Solving for this, we get 2x is equal to, I subtracted 2x from both sides, and I want to subtract 25 from both sides. 2x is equal to 20, so x is equal to 10. Now, let's find the three sides. So, MN, let's plug in. So, 4 times 10 plus 25. 40 plus 25 is equal to 65 degrees. So, since I know MN, I also know NO. They are equal. This is also 65 degrees. And then find MO, plug in as well. 3 times 10 minus 15. So 30 minus 15, so MO is equal to 15. And these are not angle. Why am I putting degree symbols? I'm sorry. Those are not angles. Please forgive me for that. Okay. So some of you may be thinking, whoa, why didn't you just add those 3 sides up to 180? You cannot do that. Never, never, never. Only angles in a triangle add up to 180, not these sides. So do not add up to 180. I'm warning you now, guys. You will make the mistake, and on the test, I will have that as one of the choices for you to choose from. And if you do that, you're gonna regret it because it'll be incorrect. All right, now, given triangle TRI, there's any triangle right here, okay? I know that measure of angle T is equal to x plus 14. Measure of angle R is 4x plus 6. And the measure of angle I is 15x plus 40. So instead of determine the measure of each of the 3 angles, I want you to say, this should say is triangle TRI isosceles. The only way for us to figure that out is to see if any of the angles are equal. So we have to find the measures of the angles. So I know the angles in a triangle add up to 180. So we can say x plus 14 plus 4x plus 6 plus 15x plus 40 equals 180. So let's do some combining. So this gives me 20x. 14 plus 6 is 20, plus 40 is 60. 20x is equal to 120, so x is equal to 6. Alright, measure of angle T is equal to 6 plus 14, which is 20 degrees. The measure of angle R is equal to 4 times 6 plus 6. So 4 times 6 is 24 plus 6 equals 30 degrees. The measure of angle I equals 15 times 6 plus 40. 15 times 6 is 90 degrees. Right? Wait, 15 times 6. 90 degrees plus 40 equals 130. So it is not an isosceles triangle because none of those angles are equal. So I'm just going to say not isosceles. And that's because none of the angles are equal. Boom. Number 12. Is an equal angular triangle an equilateral triangle? Justify your answer. Okay? So, an equal angular triangle has 60-degree angles everywhere. So, if I know that these two are congruent, obviously, right? So that means these two are congruent. And then also, if you turn your face, I know these two are congruent. So that means the opposite sides are congruent. So that and that. Oh, and look at there, all 3 of the sides are congruent. So yes, it is an equilateral triangle. And based on the justification of what I said, you can write something down for yourself. 13. Using the definition of isosceles triangle, what other kind of triangle is also an isosceles triangle? So, if 2 sides are equal, it's at least 2 sides are equal. So that means that if 3 sides are equal, it's also isosceles. So an equilateral triangle is also can be technically classified as an isosceles triangle. All right, and that is the end of the video for 13.2, and that ends the videos for activity 13. Your test is going to be on 13 and 15. Okay, so our whole video series will be 13.1, 13.2, 15.1, 15.2, 15.3, 15.4. So the next video you should watch should be lesson 15.1. All right, thanks for watching, guys. If you have any questions, of course, email me at my email.